So today we're going to talk about a couple theorems regarding tangent lines and circles. This is where things start to get a little more interesting in geometry with circles, but they're not too difficult. First one, if I have a radius of a circle, which I have right here, and I have a tangent line, which we have right here, and they intersect at the point of tangency, which is P in that picture, that forms a right angle. And obviously, as soon as we get a right angle, all sorts of things start happening because we can have right triangles, which means we can incorporate trigonometry, we can incorporate Pythagorean theorem, all sorts of things because I have a right angle. So having a radius and a tangent line being perpendicular, that's really going to be powerful for a lot of things that we want to do. The other theorem we deal with is the external tangent theorem, and that is if I have a common tangent or two common tangents that intersect at a point outside the circle, which only makes sense because if they're tangents, they couldn't have points inside, that those two must be congruent. That from the point of tangency to the point of intersection equals the point of tangency to the point of intersection. So again, fairly intuitive. It's not something that you have to work through and do a lot of math for. They're congruent. Not difficult. So, first question, is segment ST tangent to circle P? Well, if it's going to be tangent, that means that that has to be a right angle. So I guess what we're checking here is this a right triangle, or is angle T a right angle? The way we check that, of course, is with Pythagorean theorem. So 12 squared plus 35 squared. And what's the relationship between that and the hypotenuse? 37 squared. Now again, be really careful when you're setting this up that you get the hypotenuse being the value that's by itself over here in the Pythagorean theorem itself. And we do the math because that's what we do. It's math class. And 12 squared is easy. That's 144. But 35 squared, actually I have to type that in myself. So 144 plus 1225 is 1369. And compare that to 37 squared, which is 1369. That is indeed equal, meaning this is a right angle, which means that, yes, tangent. Since that's a right angle, that's a tangent line. If it was anything other than a right angle, we wouldn't really have to discriminate between obtuse and acute here. We just know it's not right. We're kind of looking right, not right here. And if it's right, it's a tangent line. If it's not right, it's not a tangent line. This is a more interesting problem. Find the radius of the circle. Given that B is a point of tangency, so AB is tangent to the circle, and we have the given measurements. Now, this is a little bit trickier because obviously my hypotenuse is AC, but the length of AC is 50 plus R. And I'm going to have to square that. So R squared plus 80 squared equals 50 plus R squared. And so from an algebra standpoint, this is a more complicated problem. A lot of students make the mistake of seeing the 80 as the biggest number, and they put the 80 in for the hypotenuse. But that's not the hypotenuse. The 80 is one of the legs of my right triangle. The hypotenuse is always the side across from the right angle, and obviously here my right angle is B, and there's my hypotenuse over there. So be careful. Now we have to do the algebra. Well, R squared is simply R squared. 80 squared is going to be 6,400. But 50 plus R squared, here's where we do a little algebra review. 50 plus R squared does not equal 50 squared plus R squared. It doesn't work that way. Just a reminder from Algebra 1. I cannot distribute an exponent over a sum or a difference. When I get 50 plus R squared, that means 50 plus R times 50 plus R. It's a FOIL problem. First outside, inside, last. We have to FOIL this out. So 50 times 50 is 2,500. Plus outside, 50 times R is 50R. Plus inside, 50 times R is another plus 50R. They do not cancel out. They're going to add. And then R times R is R squared. So when I combine terms, I get R squared plus 6,400 equals 2,500 plus 100R plus R squared. Now this looks super duper hard because it looks like we're going to have to solve a quadratic. But something really nice happens. When I go to combine R squareds, they cancel out. So I get 6,400 equals 2,500 plus 100R. And now I just have a normal linear equation, which we solve using our normal techniques. That is 3,900 divide by 100, and R equals 39. So the radius of that circle is exactly 39 units. But the real trick here is, again, setting it up properly and FOILing it out properly. Because we are squaring a binomial, and that's a technique that you learn in Algebra 1, but probably haven't practiced much. You will definitely need to know that for Algebra 2. But do not make the mistake of just distributing the exponent to the 50 and to the R. Exponents don't distribute over sums. Coefficients will, exponents do not. That's just one of our rules of algebra. Back to an easier problem. Here I have RS and RT are tangents. R is outside the circle, and we need to find the value of x. Well, clearly, the relationship here is these two are congruent, so 28 equals 3x plus 4. That's our equation. I get 24 equals 3x, so x equals 8. Now, is that my solution? It says find the value of x is my solution. Yes, it is. We're done. Much easier. Now you're going to get a couple chances. First off, it's going to be a yes or no. Very simple. Is DE tangent to circle C? Answer the question. Please note, however, that the 2 in this problem is just this part here. They don't give you the full length of CE. You are going to have to calculate that. So we'll give you that as problem number 1 today. Okay. Second problem, I'm going to give you number 8 here. We'll come to back to number 7 in just a second. But number 8, this is your second question of the day. Find the value of x, or find all the possible values of x for this. Third problem, right here. And this is going to set up just like the other problem we did before. So this is going to take just a couple minutes. But r squared, leg squared, plus leg squared equals the hypotenuse, which is r plus 18 squared. Now the r squared is just r squared plus 24 squared. 24 squared, I should know that off the top of my head, but I don't right now, 576. And we have to FOIL this out. This is r plus 18 times r plus 18. So that's r squared plus 36r, because 18r and 18r, and 18 squared is 324. Fortunately for us, the r squareds cancel, and I'm left with 576 equals 36r plus 324. And now we just do the simple linear algebra. And I get 252 equals 36r. And 252 divided by 36 is 7. All right, that's the end of section 1. And we'll see you in class.